So in this video, we're going to try and sum up all the terms of this series from the very first term all the way to infinity. So when n equals 1, put a 1 into the n, the first term will be this. When n equals 2, put it into here, the second term will be this. When n equals 3, it will be this. N equals 4, it will be this, and so on. So we've got to sum up all the terms from the very first one all the way to infinity. So to sum up everything, the trick is to always try to keep an eye out for something easily square rootable, and there happens to be a minus in between. Then you can jump to square root of this, 2n, and then plus 1, and then 2n minus 1. So whenever something's easily square rootable, and there happens to be a minus in between, you can jump to something like this. So rewrite this as this. So now our job is so here you've got one fraction multiplying another fraction. So our job is to break it up into one fraction plus another fraction. So up here you've got one fraction times another fraction. Here, our job is to try and break it up into one fraction plus another fraction. So we've got to find a and b in such a way that this would be the same as this. So this is us doing partial fractions, and we've seen this in the past. So remember, we are trying to seek a and b in such a way that this whole thing here will be exactly the same as this thing here. So hang on. So we are trying to seek a and b. So now here we've got one fraction plus another fraction. So let's if I were to ask you to merge these two fractions together, you would do this. So remember, this is what we're doing here is partial fractions, which we've done before in the past. So times top and bottom here by 2n minus 1, and then over here times top and bottom here by 2n plus 1, and then this thing here will then become this. So now we've got to try and seek a and b in such a way that this whole thing here will be the same as this thing here. Remember, we've got to seek a and b in such a way that the two will be the same for all n. So now hang on. So now we've got to try and seek a and b in such a way that this whole thing here equals this. So let's just concentrate on making this to be the same as this. So try and seek a and b in such a way that the numerator will be the same as this numerator. So it really takes us to this. So now remember, this has to satisfy for all values of n. So let's select an n where let n be a half. So let's put a half into here. So this will be 1 take away 1 will be 0. So this thing here will be, so when n equals 0, remember, we are trying to seek this to be true for all values of n. So it should work for all values of n. So let's put something easy in there. Let's put a half in there. This thing here disappears, leaving you with just this block. This block equals this side here. So we blah 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 blah. B must be a half. B must be 2. So now to seek a. So going back to here. Now we know b. Let's try and seek a. Let n be negative a half. So put this into here. This would disappear, leaving you with this. So now we would blah 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 blah. A must be negative 2. So now we know a and we know b. So going back to here, we now know a is negative 2. So we can put negative 2 into the a. We know b is 2. So we can put the 2 into the b. So that will then give us this. So now let's just switch these two around. So let's put this in front and this behind. So that will then give us this. It's pretty much the same, but just it looks neater here like this. Okay, so this thing here is exactly the same as this. So the point here is that this was what we were trying to seek. This was what we were trying to work out. We can rewrite this as this. Okay, so now if you look at this, so hang on, so wait there. So here we are summing up everything from the very first term all the way to infinity. So we're summing up everything from the first term all the way to infinity. But here we are just summing up to an arbitrary. Hang on, let me go back to one. Let me go back one step. So here we've got what we've got here is this. Hang on. So here you're just trying to sum up something from 1 to infinity. So that's the same as you doing this plus this plus this plus this plus this all the way to infinity. So this is us doing it all the way to infinity. So this is us summing up the first term all the way to infinity. But then down here we're taking a partial sum. So we are summing up from the first term to, let's say, to an arbitrary term n, to the first nth terms. So we are summing up the first nth terms. So this, us summing up the first nth terms would be us doing Sn. Remember, this notation here, S on its own, would be us summing up everything from the first term all the way to infinity. Sn is us summing up from the first term to the nth term. So up here we are summing up everything from 1 all the way to infinity. Here we're summing up the first nth terms. So that will then give us this. And then later on we can take the limit as n tends to infinity. Then that will then give us this thing from first term to infinity. So the first nth terms would give us this, because looking at this, when n equals 1, you put 1 into here, this will then become this. When n equals 1, this thing here will then become this. Now when n equals 2, put into here, this thing here will be this, this would be this. When n equals 3, this would be this, and then this would be this, and so on, plus blah blah blah, and the very last term would be this. Well, the very last term up to the nth term, it would be this, and the term previous to the nth term would be this. So basically, you put n minus 1, you put n minus 1 into here, and then you put n minus 1 into here. That will then give us this, and the term prior to this term would be this one here, and then you've got a lot of things in between. So you're summing up everything from the first term all the way to the nth term. So that will then give us this thing here. So now let's tidy this bit up. This times this times this, and then simplify this, simplify this, simplify this, simplify this. Don't need to simplify that. So simplifying these bits here will then give us this. Will then give us this. So will then give us this. Okay. So now you've got to, if you look at the pattern here, let's compare this, the first bubble and the second bubble. If you look at the right hand side of the first cancels out with the left hand side of the second. So these two will cancel out. Now if you compare this with this, remember the pattern is this, the right hand side, the second of the first will cancel out with the first of the second, if that makes sense. So these two will cancel out. So when you get to this stage here, the trick is to recognize the pattern here. So compare this. This will cancel out with this. Right hand side of the first cancels out with the left hand side of the second. So right hand side of the first cancels out with the left hand side of the second. And then if you go all the way to the end, let's compare the very last term and the one before the very last term. So the right hand side will cancel out with the left hand side, and then now let's compare this with this. The right hand side will cancel out with the left hand side. So you can see that this will cancel out with this. So as it turns out, this will cancel out with this will cancel out with with, hang on, let me go back one step. This would go back, this would cancel out with this, and then this will cancel out with this, and this will cancel out with whatever's here, and then hang on, let me think, and then hang on, let me think. This will cancel out with this, and then looking at this, this will cancel out with this. Yeah, and this will cancel out with what was previous here. So all that you're left with is this and this. So Sn equals this plus, well, Sn minus this thing. So that would then give us this. Okay, so this is up to the nth term. So now we've got to take the limit as n tends to infinity. So the minute we take the limit as n tends to infinity, this thing here becomes it becomes us summing up everything from the first term all the way to infinity. Yeah. So take the limit as n tends to infinity of this. That would then give us 2. So you summing up from the first term all the way to infinity will add up to 2. Okay.